All right, welcome everyone. I'm going to make sure that the audio works appropriately. Testing. I'm going to make sure that the audio works. Okay, good. So I am, today I am going to do some automation. I'm going to play around with a subject called VLAN translation. So what is VLAN translation? I'll do a quick overview of what I'm trying to accomplish, or overlapping VLAN namespaces or domains in EVP and VXLAN. So that's the overall title of what we're doing here. And it works like this. So let's say I've got a switch here, and oops. Don't need to put it on my phone there. So let's say I've got a switch here. So this will be leaf 1. My whiteboard is PowerPoint. And I've got some interfaces here. So Ethernet 1, Ethernet 2, and Ethernet 3 and 4. Still working on a color scheme. I want to do a dark background and white text because I think that works better for the way we consume content today. But the problem occurs when we have, so let's say I've got a hypervisor here. And I want to do VLAN 10 up here. So it'll be trunk port. And then I want to do, let's say VLAN 10 and 20, just 10 and 20 on this interface here. Trunk that up there. And we'll just call this project A. And then I've got another device here. It's another ESXi host from the same project. And they're also using VLAN 10 and 20. Make them a little smaller, slimmer. So what happens if, like, the company I'm working for acquires another company and they've got their own VMware set up, or their own whatever they've got going on, and they're also using VLAN 10 and 20, but we need them to be different VLAN 10s and 20s. So what are we going to do? With EVP and well, you can do it with regular VLANs too, but with EVP and VXLAN, this comes up with a discussion of what happens, you know, why don't we actually get more than 4,000 VXLAN segments? So one of the purported benefits of using VXLAN has long been that you get 16 million segments. It's 16,777,216. I have that number memorized because I've been teaching EVPN for the past 5 years. And so while it has a much larger numbering space, so over 60 million VXLAN segments, we can't make use of that many, nearly that many, because at least in when we're dealing with physical switches, every VXLAN segment has to be sent to a local VLAN. So on a given switch, we're limited to 4,000 VXLAN segments because we only have 4,000 VLANs to assign to the VXLAN segments, the VNIs. There are some ways around this, but for the most part, what people do is they just use a global VLAN domain. So VLAN 10 is the same everywhere. Every switch assigns VLAN 10 to the same VNI and vice versa. And so we have a global namespace. We treat VLANs as if the numbering was globally significant. It's not. You could assign a different VLAN for every switch to the same VXLAN segment, but we don't do that because it would be crazy and it would be hard to keep track of. If you've ever worked with Cisco ACI, that's what they do inherently. It's kind of confusing, but every bridge domain is like a primary private VLAN. And then every EPG is like a secondary private VLAN attached to the primary private VLAN, with the gateway being the promiscuous port. It gets kind of confusing. But if you send a tagged frame into Ethernet 1 on a leaf in ACI, or Ethernet 10 rather, let's say Ethernet 10. So if tagged frame comes up into Ethernet 10 into a leaf, it gets translated into an internal ephemeral VLAN, a VLAN picked randomly that's not used, and that's what's attached to the VXLAN segment. So what we're going to do today is explore some options. If you ever run into a situation, what would happen if you had a situation like this, where you had two different sets of systems trying to use VLAN 10 and VLAN 20 and VLAN whatever. So two different VLAN domains. And how are you going to handle that? Well, we can do that with VLAN translation and VXLAN. So what we would do is that on a VXLAN configured switch, every single, man, these color schemes are not good. This is really something I got to get figured out, is the coloring schemes. It's kind of burning my retinas. Let's do fill here, and I think if I do the transparency, it helps things out. Oh yeah, there we go. So every VXLAN VNI, so that's VNI is equivalent to a VLAN, or close enough for our purposes, must be assigned to a local VLAN. And what we could do is we can play around with that so that we have different VLAN domains. So let's say this is, call this here. So VLAN domain A. One way is we could just switch it. We could just have different switches, have different VXLAN assignments. But we need an extra column here. So this will be our external VLAN. And this will be our internal VLAN. So let's just start with two domains right now. We'll just call them A and B. So the external VLAN ID is the VLAN that comes into the switch. That's what comes into the front-facing port. And then the internal VLAN ID is what we translate it to and what we set it to. In fact, I should probably switch this. So internal VLAN, let's do this. We'll do from left to right, from the outside of the switch to the inside. So this would be external VLAN ID. This would be internal, it's the same. And then we would have L2 VNI. Let's do it that way. I think that makes more sense. And we're going to go over the configuration, and we're going to go over how I would automate this. I have an idea. I haven't actually done it yet, but I have an idea of how I would automate this. So the external VLAN ID coming into the switch, we're going to do 10 and 20 because I'm not going to have that many servers. I'm going to do 4 servers with 2 VLANs. So we'll have to pick an internal VLAN. We'll do 1010 and 220. And then it'll be 10,010, 10,020. The external VLAN here will be 10 and 20 as well. So we're going to use the same 2 VLAN IDs externally, but we're going to translate them internally to different VLANs. Now, one of the things that we're going to do is, that makes sense there. We are going to keep the VLAN to internal VLAN mappings consistent. So we're still limited across the fabric to only 4,000 layer 2 VNIs. You can stretch this even further. You can scale this a lot better if the internal VLAN is random in an available internal VLAN on the switch. And it might overlap with some external VLANs. That's okay. But the problem is you have to have a way to keep track of all that. You have to have a state of your ephemeral internal VLAN assignments. And that's going to be a little bit too difficult for this live stream. You can do it, and that's what ACI does. But I really don't feel like trying to architect a state machine to do this. I have some ideas how I would do it. I'd probably do it in just like a JSON file that gets loaded and rewritten every time we generate the configs. The other thing is that if those internal VLANs change, it might result in packet loss. I haven't tested it to see how it handles changing the internal VLAN. Would there be packet loss? Would there not be packet loss? And I can't even really test it because I'm using virtualized instances. And so the way the ASIC would behave is going to be different. It would probably be different in that regard to how the the virtual instance would behave. So I'm doing this on Arista EOS, on containerized EOS with Container Lab, because it is by far the lightest weight of all of the major network operating systems. It's only about 1 gig a node, so you can make some pretty big fabrics. I've made a 60-node fabric on 16 CPUs and 80 gigs of RAM, and it works just fine. I got my Kroger sparkling water and my blackjack gum and a feeling that something nerdy is going to go down. Anyone get that quote? Anyway, so this will be VLAN domain B. So this is what we're going to do. Is we're going to have 2 different VLAN domains, and we're going to set it up so that we're just going to do this because it's going to be easier to work with here. VLAN 10 and 20. So we'll have 2 different tenants, if you want to call them that, using the same, using overlapping VLANs, and it'll still work. Like VLAN 10 for project A will be different than VLAN 10 for project B. So let's go ahead and do that. So the first thing we're going to need is a VXLAN fabric. So let's go ahead and build us one. And before we even get into that, we need to actually create the virtual environment. So I've got so we've got this system here. It's got 80 gigs of RAM. It's a virtual machine. This that you're seeing right now is something called code server. So it's VS Code running as a web application on a Linux VM that's got Container Lab on it, but it also allows me just to edit stuff locally, and I've got a terminal window. So I use this instead of SSH now. It's a pretty cool system, and I've got a whole set of scripts that'll build this up. Pretty nice. But what we need to do is create a Clove fabric. So I've got this one that I've already used before, but we're going to change it. So we're going to call this VLAN overlap. And get my management network. I'm not using IPv6 for management. I was running into some issues with it before. Mostly just laziness on my part. But I probably will add it later because I'm going to build an IPv6 based fabric because it's going to be the easiest to do. But we're not there yet. So what I want to do is I want to build a fabric. See if we can find something I can copy here. All right, so this is VLAN translation. I'm going to I'm going to show you what I'm going to build first. So, example fabric. So I could do just 2 spines. I'll do 3 spines. I've got 80 gigs of RAM, so I'm not worried about the number of nodes that I'm doing. I'm not going to do MLAG, and I'm not even going to do EVPN all active. I'm just going to do a single node, single homed, because that's the multi-homing is not what we're concentrating on. So no multi-homing. Do I even need to do, how many switches do I need to do? So host 1, and then this will be a different. Call this B. And I want to plug it into the same switch just to demonstrate. And then I'll do the same thing over here. So maybe just plug everything into Leaf. One and 3. Yeah, I'll do that. That's fine. So maybe I'll just do 2 leaves. Yeah, maybe let's make this simple. This is less stuff for me to configure. Let's get rid of these. This is going to be a fairly unique topology. I wouldn't probably do this topology for anything else. Yeah, I think we'll do it this way. So I just have to represent this in my container lab. So if you've ever worked with Container Lab, it's fantastic. I love it. I've got some instructions on how to build a Container Lab environment that looks like this. So it's got code server in it. So it's got all the instructions on how to build it up. Let me put it into the chat room. I call it the Autobox, and it's just a set of instructions on how to build a system. So that's in the chat room there. All right, so we're using 334. I'm just going to do a quick Docker image ls. That's just going to show me which versions of EOS that I've got. So I've got 3.4, I've got 3.32F, and I've got 3.4. I'm going to go ahead and go into, I've got a system here. I'm going to go ahead and grab that, just the newer version of it. Okay. So sudo docker image import. We're going to import it as CEOS 4350F. It takes a few seconds to get imported. So I'm just importing into my image image repository so I can load up a newer version. I don't think it really matters for this, but just to keep things, change all occurrences, 350F. Okay, so while it's doing this, we're just going to do 2 leaves. and we're just going to do 2 spines. We got 2 spines here. Host 1A, host 2A, and then I'll copy and host 2B and host 1B. R1, do I want to do an R1? An R1 would be a router connected to typically one of the leafs. Just to test some external connectivity. Yeah, why not? Doesn't really. Pretty easy to add here. So this will be R1. And we'll plug that into leaf 2. And so we'll do some, we'll figure out how we connect that to the outside world using some like VRF Lite configs or something like that. All right, so so this is the part here that's pretty tricky. I'm going to get rid of all the leaf 1 to leaf 2 and leaf 3 to leaf 4 because we don't need those. These would be the interleaf links if we were doing like MLAG, which we're not doing MLAG. So spine 1, we're not going to plug the spine 1 and spine 2 into each other either. So leaf 1, Ethernet 1 is going to go to spine 1, Ethernet 1. Leaf 2, Ethernet 1 is going to go to spine 1, spine Ethernet. This part gets a little tricky to, you got to keep track of all this stuff. So leaf 3 and leaf 4, there is no leaf 3 and leaf 4, so that's easy there. So, and then leaf 1 and leaf 2 on Ethernet 2 goes to spine 2 on Ethernet 1. Ethernet 2. Yeah, so that's what gets tricky. And we're not going to dual home R1. We're just going to connect it into leaf 2 on Ethernet 3. Okay, and then we get to the hosts. So host 1A on Ethernet 1 is going to be connected to leaf 1 on Ethernet 3. And host 2A on Ethernet 1 is going to be connected to Ethernet 4. And then I can copy and paste that here. So that would be, is that how I did it? This is why I always do a quick visual diagram beforehand. Like I don't need to be specific about what links plug into what links. Although if I really got complicated, I would do that. So host 1 is plugged. Okay, so I gotta fix that. So host 1 is plugged into leaf 1 and host, so this is 1B. And then, again, pretty simple. Host 2, leaf 2. Yeah, so we're not getting complicated. We're not throwing in other technologies here. We're just sticking to a basic EVP and VXLAN standard. And you could do this. You could also do this with. Oh, you know what I should do? I'm gonna add a third host, and it's not gonna be VLAN tagged. So host 3A, that would be green. And just to show, so host 3 will be an access port, and we'll just, in doing that, we'll just translate directly into the internal VLAN. We'll skip the external VLAN because we don't need the external VLAN. We'll see how that, see if that changes anything. Do I want to? Yeah. Yeah, that's fine. That's a little confusing, but There we go. Because it doesn't really matter where we plug it in. Not mattering where we plug it in is called workload mobility. It includes the ability to do things like vMotion, but it really doesn't matter. Even if you don't do vMotion, just being able to put any network in any rack on any leaf is, we consider that workload mobility. So, let me do, oh, these are overlapping. Host 3B. Host 3A. My management addresses are overlapping. Okay, host 1 through 3. So 2, 3, 4, 5, 6, 7. All right, I think that should be it. Oh yeah, I need to add the host 3A, Ethernet 1, 1, Ethernet 5, host. I think I got this mixed up here. So host 1A, host 2A, host 3A, 3, 4, 5. Host 1B is on leaf 2, so I think these two are not necessary because we're not dual homing. 1A, 1A, 2A, 3A. I feel like I'm doing the destruct sequence for the enterprise. Code 1, 1B, 2, 3C, which is like the dumbest destruct code. So 3, 4, 5. Then so host 1B, host 2B, host 3B is on leaf 2, 3, 4, 5. Okay, good. And R1 is on leaf 2 on Ethernet 6. I think that will work. So let's go ahead and try this. And we should probably just rename this. Call this Clo Xlate. Oh, I need to have the name CLab in there. Clo Xlate. Yeah, I can get rid of that. Okay, Container Lab, deploy. Duplicate. Okay, so I've got some duplicate things here. So spine 1 duplicate. Okay, yeah, so that should be Ethernet 2. That should be Ethernet 1. Okay. Oh, yeah. This is the way I'm doing this. 1, 2. All right, let's try that. So leaf 1 on Ethernet 1 is plugged into spine 1, Ethernet 1. Leaf 1, Ethernet 2 is plugged into spine 2, Ethernet 1. Okay. Leaf 2, Ethernet 1 is plugged into spine 1, Ethernet 2. Leaf 2, Ethernet 2 is plugged into spine 2. Okay, that should work. What do I have here? Oh. Am I in the wrong directory? Where am I? Got myself all mixed up here. Yeah, I'm editing the wrong file. Or what is going on here? I ended up with too many files. Okay, endpoint spine 1, duplicate, endpoint spine 1, duplicate. Oh, everything I just fixed I broke here. So Ethernet 1, leaf 1, Ethernet 1 goes to spine 1, Ethernet 1. Leaf 1, Ethernet 2 goes to spine 2, Ethernet 1. Leaf 2, Ethernet 1 goes to spine 1, Ethernet 2. Leaf 2, Ethernet 2 goes to... Okay, try that. 92. Yeah, it did. So that would be 3. Okay, try that. Reconfigure. All right, there we go. So while this does that, we're going to go into, it creates an Ansible direct, it creates a inventory direct, or an inventory, well, it's not done with the inventory yet. So it's working on that. So we got 2 Ansible directories here. They're a little confusing, but that is okay. I'll just do a quick host 3A, or I'll do the comma 3, and comma 3, the little shortcuts. So host 1 through 3-A, host 1 through 3-B, and we got R1. And then we need something there. So this will be my basic inventory file. And then I have something here called setup nodes, which is going to copy a bunch of stuff and set up some stuff. So I'm going to go into Ansible and Ansible playbook and just set up nodes. So very basic setup, just to set up some nodes. If I did the right one, I don't think I did the right one. Shoot. Nope, it should be okay. All right, there we go. So what that does is it installs my SSH key into some other stuff, so I can go to SSH leaf 1, and I get dropped right into privilege exec mode. So that's perfect. That's what I wanted. All right, so now we're ready for, I've got things set up. I just need to add the inventory file. So this is my template engine. It's Ansible, and then it builds stuff from variables, like fabric variables. So this just tells it loop back IP addresses and stuff. Then inventory tells it to run through eAPI and all that, so it should already be there. And then I've already got a little bit of a template here. But before we do that, let's go ahead and just configure leaf 1 and spine 1. So I'm going to go into leaf 1. Oh, you know what? I'll do this as spine 1. Just to get an idea of what we're going to build in the template. So I'm going to go config mode, int loopback 0. I'm going to do IPv6 only for the underlay. So no IPv4 for the underlay. It's going to be eBGP using link local addresses, and then even the loopbacks will be IPv6. So loopback, that's going to be IPv6. Address will be, what's the documentation subnet? (2001) DB8. And then I'll start for I'll do 1 for as the we'll do 0, and then 0 will be for loopback 0 range. And since it's spine 1, I'll do 101 -128. And there's no loopback 1. And show LDP neighbors. Interface E1 through 2. No switch port, IPv6 enable. That's all I got to do. And that's the IPv6 part. So I'll do the same thing down on leaf 1. So config mode, interface loopback 0. IPv6 address 2001 DB8 0. Is that what I did? I did 1. Yeah. And 1. Because it's leaf 1. And then show LDP neighbors. Int E1 through 2. No switch port. IPv6 enable. And I don't think so we have the FE80 addresses there, and we got a loopback 0 address, so that's good. Since we're doing eBGP, let's come up with a numbering scheme. So this would be 65,001. And then 101 and 102. Those are numbers I use all the time, so that might as well stick with that. So IPv6 unicast routing. Router BGP. Oh, you know what? I do have to configure a loopback 0 address or router all. Router general. Router ID. We'll do 101. Because we do need a router ID. So this way I don't have to configure an IPv4 address in the thing. So router BGP 6501. That's okay because we have IPv6 routing. And then router ID 111. And then we do neighbor underlay peer group. Neighbor underlay remote AS 65001. Neighbor interface E1 through 2. Peer group underlay. Then no BGP default IPv4 unicast. And address family IPv6. Neighbor underlay activate. And network 2001 DB8. Oh, did I not? Oh, yeah, that's right. Network 2001 DB8 28. So show IPv6 BGP neighbors. Trying to do this memory and I'm forgetting some stuff, I'm sure. All right, so let's go ahead and do this config. So IPv6 unicast routing, router general, router ID, IPv6, or IPv4. Let's do 11.11.11. And then router BGP 65,001. Darn it. This is why I do automation. I'm just doing this to get so I can make the template. I've got an idea for a template, but it's a little bit complicated, so I want to make sure that I get this situated. So no router BGP. Router BGP 65101. And then just copy and paste that. Router ID. Underlay peer group neighbor. So we don't set a number there. Interface 1 peer Ethernet 1 peer group underlay remote AS 65101. Neighbor interface Ethernet 2 peer group underlay remote AS 65102. Address family IPv6 neighbor underlay activate and network show IPv6 interface brief. And we're going to advertise our 128 into that table. There it is, established. And if I do show IPv6 route, we have to loop back in the routing table. So pure IPv6. I could do RFC 8950, or what used to be called 5549. But I figure it's just better just to do IPv6 on the underlay entirely. That way I don't have to worry about colliding with other RFC 1918 address space used elsewhere in an organization. This I've got so much room for activities if I use IPv6. So we do that. And then leaf 1, I also need interface loopback 1. IPv6 address 2001 db8 1 1. Okay, and then router BGP. That's gonna be kind of annoying. So we'll do network 2001 db8 1 128. So I should see that in there. There it is. Perfect. Then we'll do the so that's the underlay for leaf 1 and spine 1. Let's do the overlay real quick. So that is so we'll do neighbor EVPN peer group, neighbor EVPN remote AS is 65,001, neighbor EVPN source, what was it, BGP update source, let's loopback 0, multi BGP multi-hop. And then send community. I always do extended just because it's a habit, but you don't have to do it extended in EOS. So this is to appear the overlay, the IPv6 or the EVPN route types. And the neighbor EVPN so neighbor 2001 db8 101 remote AS remote, I don't have to do remote AS peer group EVPN and 2 address family EVPN neighbor EVPN activate show BGP EVPN. Okay. And then over here, I do the same thing. Is show neighbor EVPN peer group, neighbor EVPN eBGP multi-hop, update source, loopback 0, community, send community, extended, neighbor 2001 db8 Oh, I did not. crap. No, do these. I have to specify their AS number. Messed up the config here. Show BGP summary. There we go. So now we're exchanging EVPN routes. So that's the underlay and overlay. Pretty easy, pretty simple. And I'm going to start configuring the hosts. So if I go to host 1A, and I just want to, host 1A, and then I'll do configure Ethernet, show LDP neighbors. So Ethernet E1, no switch port, interface E1 10, encapsulation VLAN 10. Or encapsulation VLAN encapsulation.1Q VLAN 10. There it is. And then IP address 10.1.10.11. If we go to host 3, and E1, no switch port, IP address 10.1.10.13. So now I've got to make a table. So I'm just going to do a simple, just to keep track of it right now. So this will be VLANs.yaml, and then tenants. Call this group A. We'll do it by VNI, so we'll keep track of things by VNI. Now, do I want to make this a list or a dictionary? That's a question here. So I'll show you what they both would look like. So if the key is VNI, and then underneath of it we would have internal VLAN ID, and then we would have we would just so internal VLAN ID would be 110, VNI 10,020, internal VLAN ID 120, and then group B VNI 20,010, internally we would translate it to VLAN 210. Doing a lot. We got a lot going on here. All right, so this, so it should be this. Yeah. So I was doing it all wrong. There we go. So that's what it would look like if I was doing as a dictionary. If I did it as a list, we would still have the tenants. So I could do like name group A, VNIs, and then that would be a key, and then under that would be L2 VNI would be 10,010. External VLAN would be 10. Oh yeah, I don't have the external VLAN in there. Internal VLAN would be 110. So this is a little bit more of a modern approach. This one's a little bit easier. Or maybe I'll do a combination of both. So for the tenants, I'll still do that, and then because what am I going to loop through? I am going to have an L3 VNI. Because we're going to need that when we do IRB. I kind of like this for now. Yeah, I kind of like this for now. So we'll do this. Now, there's more than one way to do it, and usually there's more than one right way to do it. This looks okay to me. When we start writing the template, we'll get a little bit more in depth, but we're good for now. So I've got things kind of, at least I'm keeping track of it. So the spines we don't care about because they're not going to do anything. So interface VXLAN 1, and we want to do encapsulation, or VXLAN encap is IPv6. Something to keep in mind. So interface E 1 through 2. MTU is 1570. It's a 70 byte header when you do IPv6 underlays. It's not a 50 byte header, it's a 70 byte header. So I'll do that over here too. Interface E1 through 2 is MTU 1570. All right. And 1570 would let my host have a MTU of 1500. I usually don't like to do, if I'm in charge of the network, I'm not going to let people do jumbo frames in the host unless there's a very good reason to. I'm not a big believer in jumbo frames for most situations, because MTU mismatches are not very fun to try to diagnose. But we're doing this manually right now. So we're connect. So Ethernet 3. So this would be switch port mode trunk. Switch port trunk allowed. Well, we'll have to do VLAN 10. We're not there yet. Okay. Interface VXLAN 1. VLAN 10. No, VLAN 110. L2 VXLAN VLAN 110. VNI 10,010. That's it. We'll do the other one too. 120. 2020. We're not gonna do the IRB. Well, actually, we do have to do the IRB. So that'll be VRF instance is group A. And then interface VXLAN 1 is VXLAN VRF group A, VNI 10,000. Then we'll do IP virtual router MAC address. Charlie 73 99. I always have this MAC address memorized. So interface VLAN 10 110. VRF group A, IP address virtual, and 1. Oh, I do have to turn on IP routing because we are going to do this. So this would be 10.1.10.1. Okay. Okay. All right. So, and then, should be enough for us to ping at this point. Oh yeah, we need to show LTP neighbors, interface E3, switch port mode, trunk allowed VLAN 110. Now, here's what we got to do. Switch port translation trunk translate VLAN. Switch port true VLAN translation 110 to 10. Oh, we need a VLAN 10. No, it's the other way around. No VLAN 10. Yeah, I got this mixed up before. Switch port VLAN translation outside, inside. There we go. Show interface VLAN 110. There we go. So it's on Ethernet 3. So at this point, if I go down to host 1, I should be able to ping 10.1.10.1. Theoretically. Oh, I didn't put it on the right. What the heck did I do? Ethernet 110. Encapsulation .1Q VLAN 10. IP address 10.1.10.11. Another thing I like to do is MAC address router. I like to hard set a MAC address that I'm going to be able to recognize in the VLAN table and the BGP EVPN tables. So this should be able to ping now into there. Show MAC address table VLAN 110. Okay, it doesn't show up there yet. Let's see if the connection works. So what we'll do is interface E3. Make sure I'm plugged into the right place. Switchport mode trunk. Switchport trunk or mode access. Switchport access VLAN 110. Sometimes the ARP doesn't work in these virtualized environments. Try that again. All right, do some troubleshooting. So Ethernet 1 is connected to Leaf 1 and Ethernet 5. That's why I'm doing it on the wrong interface. Jeez. What? I'm on a host 3, that's why. Host 1A. Config mode, interface E1, no switch port, interface E110, encapsulation, .1Q, VLAN 10, IP address 10.1.10.11. And then over here, I'll just do interface E3. Switch port mode trunk, switch port trunk. Loud VLAN 110. Switch port VLAN translation. Outside, inside. Now, ping. There we go. Oh yeah, then I want to do MAC address router ping. There we go. That makes things a lot easier when you've got when you have those hard set MAC addresses. So I can just recognize it instead of trying to like figure out which one of these. All right, so we're translating on the outside. Now let's go, we'll do the leaf. Might as well just kind of configure all this manually, at least for now. So VRF instance group B interface. So then we want to do VLAN 210 and interface VLAN 210. And then IP address 10.1.210. Yeah, let's overlap the IPs too. Why not? It'll be in VRF group B. Did I do that for show run? Yeah, I did. Okay. Now I'm going to go into host 1B. Also VLAN 10. I'll do a different IP address just to show we can't ping them. And the MAC address router. And we'll differentiate them by their MAC address. So host, that's not plugged in there. Did I not plug these in the way I thought I did? I did not. That's okay. Let's go into leaf 2. Let's go ahead and just configure leaf 2. We won't do spine 2. I interface loopback 0 IPv6 address FF 2001 DB8. Is it DB8 or DB9? I don't know. That doesn't really matter. Router used in a gateway appliance into the data center network. Leaf 1 is an Anycast gateway. And Leaf 2 will be Anycast gateways. I'm actually going to go take... yeah, so in the... so Leaf 1 will be... We're going to... So go by color. Although, what I might have to do is I might have to just erase everything and start over. Or I'll just change the diagram. Because excuse me. Because host 1A, all the A's are plugged in there, but that wasn't what I was trying to do. Let me use the restroom and I'll be right back. Alrighty. Go get some more coffee too. Alrighty. So I made a boo-boo in that the diagram that I thought I made is not what ended up. I made a here. This is not what I was wanting to do, because I plugged all the A's in a leaf 1 and all the B's in leaf 2. So that wasn't my intention. Host 1. So I'm going to fix this, but then I have to tear everything down and set it back up. And I don't know if it's going to keep the configs. It should keep the configs. But I'm going to... I've got a script that will back up the configs. So I'm going to run that script just in case. I believe it'll keep the configs when I rewire everything, but not 100% sure. So I got a script over here. Backup configs.py. So those are all the devices. You know, that's, so I'm raw dog in Python here for this. There is an Ansible module that'll do this. You know, half of one, two of the other. This is one of the problems when you are mixing between raw dogging Python and Ansible, is that you have to have two different ways to do inventory. Now there's a Python module that can import a Ansible inventory file in, but we're doing just something simple here. So that's my device list. It's just going to go through them. And I'm going to, verify false, so I don't care about SSL certificates. That's a whole other thing, is SSL certs. Because the API that we're using is HTTP based. And that can cause some interesting things. So let's run this backup. There we go. All right, so now I feel more confident when I'm redoing this, because in case it like erases the configs, I think it'll keep it, but I'm not 100% sure. Because what I want to do is that I'm using VLAN 10 on this link and VLAN 10 on this link, and they're two different VLAN 10s. That's the whole point about this overlapping VLAN. But I just did host 1A, host 2A, host 3A. So I want to slip that in there. So host 1B is going to be on leaf 1. And then host 3A. I'll be in leaf 1, Ethernet 5. Okay, that's fine. And then what IDE am I working? Glad you asked. This is VS Code running as a web app on a Linux system. So the Linux VM that I'm running Container Lab on, it has an instance of VS Code running as a web app. It's called Code Server. And I've got a set of instructions on how to build this. And it's called the Autobox. All it is a set of instructions on how to build this on a Linux VM yourself. I highly recommend it. It works really well. Because I'm proficient in VI, but I don't want to use VI for everything. I use VI for simple editing. I don't use it as a IDE. Okay, so back to my diagram. Host 2A. It's on leaf 2, host 2B. It's on leaf 2 and host 3B. Yeah, that's fine. Okay, so what I got to do now is I got to do CLab destroy. It's going to kill all those. And then do a deploy again. What Linux just you? Also a good question. I've been vacillating between either Debian 13 or Alma 10. This one is Debian 13. You're seeing Debian 13 right here. I've been wanting to get away from the Red Hat world just because I don't consider Red Hat stable anymore. And not in terms of like crashing stable, but they keep making moves that are against the community. Like they got rid of CentOS Linux in 2020, but they said they wouldn't prevent any rebuilders. And then 2022, they hid their source code for RHEL. So they're an open source company that hides open source. And we're trying to prevent Alma and Rocky from doing their distributions, but they both found different ways around it. So I really like Alma Linux. I just don't like the fact that it's based off RHEL. So I was trying to get rid of the RHEL world. But Debian 13 has a couple of like annoying things about it that I'm not quite convinced to move over to it. But this is Debian 13. So yeah. All right, so let's see if it saved the config. It did not. But that's okay. Now I'm going to do something here I always recommend against, which is just cutting and pasting. I'm glad I saved the configs. What are my thoughts on Ubuntu? Ubuntu, I worry just a little bit because they could do the same thing that Red Hat does. So Ubuntu and CentOS Linux. I worry that Ubuntu might pull a CentOS Linux, which is they're not really community distributions. So CentOS Linux was like, we're a community distribution. Not really. And we found out in 2020 that it's not really a Linux distribution or not really a community distribution rather, because the only community that mattered was Red Hat. Like, no one asked Red Hat to get rid of CentOS Linux. They unilaterally did it. That's not very community of them. And everyone was like, don't do that. And they're like, we're going to do it anyway. So Ubuntu is kind of the same way. Ubuntu is canonical, and they haven't done anything bad yet, in my opinion, at least. So, but they're structured very similarly to CentOS Linux in that way. So Debian is a true community distribution where they're not controlled by, it reflects the interests of the community. Now, the community doesn't always get along, and they can disagree on a lot of stuff. Like everyone, for some reason, hated systemd. And people got all bent out of shape when they started doing systemd in Debian years ago. But it's fine. I don't have any problem with systemd. I really like systemd. Systemd solves a lot of problems that we don't really realize we have. Like FreeBSD people are always harping on systemd, and then they're like, well, it's really slow. I'm like, well, yeah, but Debian 13 boots faster than FreeBSD, so it's not slow. It does a lot, but it does it really well. So Debian is a community distribution, so they're not likely. So my take is that Red Hat got rid of CentOS Linux because they felt they were losing money. Because rather than buy RHEL subscriptions, people were just running CentOS Linux, and they were. I mean, why pay for RHEL? And so my worry is that Canonical will decide that they're leaving money on the table. So even if it pisses off 95% of the people and they go somewhere else, if 5% of the people stick with Ubuntu by paying for it, then that's going to be a net positive for their revenue. And that's kind of what I think Red Hat did, is they were like, yeah, we're gonna alienate a ton of users. But there's a lot of organizations that were running CentOS Linux, and now they're just like, well, all right, fine, we'll just pay for Red Hat subscriptions. So I think that's my concern. So I was running Ubuntu for a little while, and then I just decided, well, I'll just try Debian 13 and it's fine. They do 5-year cycles, I believe, Debian 13, which is that's all I care about. I don't want to run an operating system for more than 5 years. So like CentOS 8 is still around. Or Alma Rocky 8. I think it's still around, but I don't want to be in the years 7 and 8 of a distribution. So the Alma Linux does 10 years, Rocky Linux does 10 years. Red Hat does 10 years, although they'll do even longer if you pay them more money. So there's still people rocking like RHEL 6 right now. I don't care about that. So a 5-year cycle is good for me. It's a good balance. For me, it's a good balance of like, I don't want to have to touch Linux too much. I want a Linux distribution because I don't care about distributions. I really don't. I want something that is going to be consistent, that is going to have the least amount of friction. And right now I'm kind of divided between Debian 13 and Alma 10. So I haven't quite decided yet. That's a great question, because it helps if there's just one. And it was CentOS Linux for about a decade. If you were doing stuff for work, and you weren't building your home machine or whatever, if you're doing stuff for work, I needed something to run my network automation on. It was 100% going to be CentOS Linux, at least in North America. SUSE is popular in Europe. I don't know what it's doing right now, but yeah, that's my opinion at least. Screw Red Hat. And you can tell them I said that. They don't care. What else? All right, so that was Leaf. So Leaf 2. Did I do anything in Leaf 2? I don't think I did. Yeah, no. All right, we'll just Cut and paste anyway. Oh, you know why I didn't save it? Because I didn't do a write mem. That's why I didn't save it. It wasn't Container Lab. It was me. It was me the whole time. Yeah, you can absolutely post questions. Questions are highly encouraged. Because I will likely put this into courseware at some point, so it helps to know. So what we're doing is VLAN translation. If you've just joined us, I'm going to do overlapping VLAN domains. So, for example, host 10 here will be on VLAN 10. And then host 1B will also be on VLAN 10, but it will be a different VLAN 10. So host 1 and host, yeah, so I've got two host 1s, one for the A domain and one for the B domain, or A of VRF, B of VRF. And they're both going to be on VLAN 10, but they're going to be different VLAN 10s because we're going to map them internally. So externally VLAN 10 for domain A will be mapped internally to VLAN 110. For VLAN domain B, internal VLAN or external VLAN 10 will be remapped to VLAN 210 internally. All right, so we're configuring this, and then I'm going to use some Jinja templates to just automate the config. But show BGP summary. All right, we're good there. Another question is, okay, got two questions. How can we use the ports that have negative dynamic link aggregation as inputs for my main switch? We're not doing lag here anywhere. Now, normally you would do dual homing for to your switches. You would plug your host into two switches typically. And you would use some sort of MLAG. It could be EVPN-based MLAG called ESI, or EVPN all-active, or EVPN multi-homing, depending on the vendor. It's an open standard, but it has some advantages over MLAG, although MLAG has some advantages. So that there's like vendor MLAG, so Arista calls it MLAG. And you could do it that way, and you could do LECP, but we're not doing any of that here. Oh, just in your main switch in your living room. What kind of switch is it? Another question is, when would you see this happening? Is this something that happens in multi-tenant situations? I don't see it really happening all that often, and that's another concern about this. Is like, is this even worth even doing? And I don't know. In almost all cases, it would probably be better to just renumber things, just so that you have a most of us treat VLANs as globally significant to the data center. So VLAN 10 on leaf 1 is on port 1 is the same on leaf 1 port 2, the same on leaf 100 on port 1. So VLAN 10 is VLAN 10 is VLAN 10. We don't have to do it that way. It is simpler to do it that way. And then sometimes we have to go in and we have to renumber, like you acquire a company and they've got their own VMware. They're using the same VLANs that you are. There's overlapping VLANs. Excuse me. So yeah, so it's harder to, it's I don't know if this is a good idea is what I'm saying. But the hardware supports it, and VXLAN, you can do it with VXLAN relatively easily. Well, not relatively easily, but so we're just exploring this right now. It's just just for giggles. Yeah, I don't see it very often. Cisco ACI has always been able to do it since it first came out in 2014, but I never really saw anyone doing anything with it because, again, it was just we're so used to VLAN 10 always being VLAN 10 and being the same VLAN 10 throughout the data center that doing VLAN, overlapping VLAN namespaces or domains was just too weird. People couldn't wrap their head around it. So Charlie, good top. I'm not familiar with that switch. So I don't know if you can even do link aggregation with it. So I don't know that switch. The switches I use, I've got a MikroTik switch. I like it. There's a couple. I do 10 gig now. From my workstation that you're seeing all this on, like this is it's connected by a 5 gig to my MikroTik because the cabling in my walls can't support full 10 gig. So it downshifts to 5 gig. So my switches are all 10 gigs. And then I switched to 10 gig because I do video editing, and video files are big, and 1 gig is only about 125 megabytes per second. I mean, it's more closer to 110 or 111 with overhead. But even 2.5 gig is 2.5 times that, so that's like 3 something. So yeah, it's like 325 gig, 325 megabytes per second. 5 gig would be 600 megabytes per second. So it's a pretty big difference when you're copying files over. So yeah, I'm not sure. I don't know that switching platform. Good top, but yeah, I have MikroTik. I've got a 5-port. There's some really interesting 10 gig switches. They really come down in price. So like this is a multi-gig switch. It's only 2.5 gigs. But yeah, something like one of these, if I was doing, 6-port 10 gig Ethernet, 4 by 2.5 gigs, and then 2 gig uplinks. Yeah, it's kind of like 2.5 gig's gotten really cheap. It's almost as cheap as 1 gig. But anyway, back to this. Yeah, Topher, it's an interesting problem. It's not one that I've seen anyone try to solve through network config. So I'm just trying to see if it would even, because I think people think it's harder than it is, because it's not that hard. I mean, the configuration is pretty simple. Is the extra complexity of the configuration worth what it gives us in the data center? Because we've always been like VLAN 10 is VLAN 10 is VLAN 10 is VLAN 10. And it doesn't have to be. I don't think it does, at least. All right, so I'm going to copy this. I'll put this into leaf 2. Yeah, let's just go to leaf 2 here. So IP interface loopback 0, IPv6 adder 1, DB8 2, loopback 1. Do you have a preference for data center top of rack switching platforms? Showcasing Arista, have you worked with Nexus, Extreme, or Dell? I've definitely worked with Nexus. So I used to be a Cisco certified instructor. And I kind of am an Arista instructor, but I haven't taught for Arista for a little bit. I'm still cleared to teach Arista courses, but I don't know if we'll be doing that anymore. But I haven't worked with Extreme in a long, long time. Like I worked with Extreme like 20 years ago. So, and I worked with Brocade, and some of the Brocade stuff went to Extreme. So I haven't used them in a long time, so I wouldn't consider myself proficient in them. So for data center, I've primarily been in the Arista or the Cisco world, with a little bit of playing around with some of the other platforms. Big Switch, I used to teach Big Switch because they got bought by Arista, so there was a period of time when they were like teaching that stuff. They still, I mean, they'll still offer to teach it, but I don't. The footprint for Big Switch has gone way down. Arista renamed it to the Converged Cloud Fabric or the DANZ Monitoring Fabric, but I don't see it anymore. If your input, if your input doesn't, doing link aggregation doesn't matter if you do one VLAN or many. I just don't know if that platform supports it. Link aggregation, it might not. That's a kind of a higher end feature. One thing about the data center fabrics is Extreme uses a different technology. They don't use VXLAN. They use SPB, shortest path bridging, which was created in the 2000s. So in the 2000s, there was a bunch of attempts to solve the workload mobility problem. In 2005, Intel and AMD both released processor extensions that allowed virtualization with basically no performance penalty. So you could take a physical machine, make a virtual machine out of it, and it would perform just as fast as it was when it was bare metal, as long as you had the CPU resources on the hypervisor. So that happened in 2005, 2006. Before that time, there was no production workloads in virtualized environments. After that, we started to virtualize a lot. So we needed to do the vMotion, so we needed a fabric that was layer 3, or we wanted a fabric that was layer 3 base, so we could have like 3 spines and 4 spines. And we weren't relying on spanning tree. And so Trill, shortest path bridging, VXLAN, NVGRE, there was a bunch of others that were tried. So Trill basically went nowhere. The fabric path was kind of based off Trill. That went nowhere. VCS from Brocade was based off of Trill, but that went nowhere. SPB got picked up by Extreme and became their data center fabric. But I'm not sure if I would use it. So, I mean, that's my thoughts on that, at least. All right, IPv6 unicast routing, router BGP 625.102. Oh yeah, router general, router ID, IPv4. Router ID. Always set a router ID. The only slight complication of doing an IPv6 based underlay is you still need an IPv4 address. Doesn't have to be routed or anything. You just need a number that's IPv4 compatible to be the router ID, even if everything is IPv6. It's kind of annoying, but all right. I'm gonna steal some configs here. Again, I'm copying and pasting, which is not a great idea. So I think I can do this. And network. Oh yeah, then yep, that should work. IP6 for unicast routing. Oh yeah, they've configured any IPv6 interfaces. Show LDB neighbors and interface 1 through 2. No switch port, IPv6 enable. That's why I like doing this. Show IPv6 BGP summary. All right, where's established? Advertising 2 prefixes. We got, so show IPv6 route. There we go. Some really great questions, Topher. Do you only see VXLAN, spine, and leaf in the data centers you work in? What other architectures are prevalent in the domain? There's two primary architectures. One is EVP and VXLAN. I don't see VXLAN by itself anymore because you can run VXLAN without EVPN, but there's no reason to anymore. The only reason to not do it was because EVPN wasn't available on your platform. Because VXLAN came out before EVPN. VXLAN is the data plane. EVPN is the control plane. And once EVPN came out, we got rid of all the other weird control planes that we tried to use with VXLAN. So EVPN and VXLAN. So that's maybe not extreme, but certainly Juniper, Cisco, Arista, Dell, Nokia. They all primarily, I would say today, use that as their architecture. There's a different one. It's a simpler one, and that's just core aggregation access layers. We've been doing that since the 90s. And that I see that in smaller installations where you don't need the benefits of VXLAN or EVP and VXLAN because it is more complex of a configuration than traditional like SVIs and VLANs. So those are the two I primarily see. A third one is just a simple layer 3 network, no VXLAN, no EVPN, but that only works with homogeneous workloads that don't need workload mobility. And the enterprise almost never see it. But hyperscalers might use it. And is IPv6 the standard in underlays? Not right now. It is for part of the underlay, at least. I'll preface that by saying the point-to-point links between your leafs and spines, more and more vendors and more installations are doing just IPv6 because that way we don't have to assign any IP addresses to those interfaces. So like look at my, if I do show run interface E1 through 2, show run interface E1 through 2. So this is my config for the point-to-point link between leaf 2 and spine 1 and 2. It is such a simple configuration. Where's my diagram here? Yeah, so it's such a... Normally I would have to put an IP address here, and here, and then here, and here, and here, and here. And then keeping track of all those IPs would be really confusing. So you can use IPv6 link local addresses. And it just kind of auto detects. It's like Highlander, they sense each other. So if I do show IPv6 neighbors, IPv6 has a built-in protocol called neighbor discovery. So on the other end of an Ethernet link, it'll know what the IPv6 address of that is. And it comes up with this address based off of your MAC address. So it does a lot of things for you. And that's why I really like it. Okay. Let's see here. Great question, though. All right, we're peering EVPN, we're peering IPv6 underlay, so we're good to go there. Now I can do the other stuff I want to do. So do VRF instance. Group A, Group B. VXLAN encapsulation IPv6. VXLAN source interfaces loopback 1. So I need to fix that on leaf 1 too. Now, I didn't work with IPv6 for a long, long time because I worked in the data center. And the data center, we didn't really do IPv6. But the first time IPv6 was useful to me, I'm going to change my perspective here. Kind of an unflattering angle. Me leaning back like that. It's better for my posture. So IPv6 became useful with started becoming useful for that the underlay because of the point-to-point links. And then I thought, well, might as well make the loopbacks IPv6 as well because it just makes things even simpler. Now I can still do IPv6 default gateway, so all my endpoints are still IPv4 only. It's just using IPv6 for the underlay. That's what Facebook did. Facebook moved entirely to IPv6 for their underlay. Now, they've still got IPv6 services. Like when you go to facebook.com, you can get there via an IPv4 address. But all the backend stuff that they do is purely IPv6 now. And that makes sense, I think. There's a lot of advantages to doing it just from a numbering perspective. But it is different. It's weird. It's like you've got things like /64s and 48s and 128s and figuring out why 64 bits out of the address of a 128-bit address is often just the host ID. So it feels weird wasting 64 bits of an IPv6 address just for one host. But that's what we do a lot. Okay. Yeah, and then I want to do this. Okay, router. All right, now we're going to configure the data plane for EVPN. So there's no IPv6, IPv4 translations. No, we're not doing any of that. We don't need to do any NAT or translations or anything. We're going to do IPv6 on the back end, and so it will stay on the back end. If I had a DCI data center interconnect, I might have to do some weird stuff. I wouldn't do NAT. I would do... There's a way to do an IPv6 or an IPv4 address over an IPv6 next hop. But so there might be some weird stuff you have to do there, but not on the back end. So when I create the tenants and I create the VRFs and the VLANs, they will be IPv4 capable, but the back end is purely IPv6. And you can do that on the campus too. So your laptops that plug in, your phones, your tablets, they would all get IPv4 addresses. But your backend would be IPv6, and there's generally no problem with that. Okay. All right, so we're going to do router BGP. So IPv4 routing, we're not using it, but all right. So VRF group A. Your router is approaching EOLs or router for what kind of, for like a home router? Like your Wi-Fi access point home router, or like a data center router? Ubiquity. I'll show you the router I have. My home router. I love it. There's a Geolink. GeoINet. Yeah. I have, these are cute routers. I have Flint 3. Yeah, I got this one. This is the router I got. I got it because it's got Wi-Fi 7, so it's got 6 gigahertz. That's the one I use. I replaced like a 12-year-old one. It was well beyond end of life. Okay, VLAN 110. Party auto. Target 110, 110. Yeah, home router. That's probably what I would use. It's got 2.5 gig interfaces, so that'll be faster than 1 gig if you have the interface on your laptop or servers or whatever. I wanted it because it had where is it? It's got 4 2.5 gig interfaces in the back. All right, so and then VRF group B. Mac VRF, already auto. Now target. Forgot that there. Okay. All right, show VXLAN VNI. Okay, interface VXLAN 1. Oh yeah, and then VXLAN VRF group B is 20,000. VRF group B VNI 20,000. Yeah, I liked, for me, the GL iNet. That was a nice, it had a really good, it uses, you could do an open source, it's like OpenWRT. It's got OpenVPN, so I can connect back home when I'm on the road. So I really like it. Okay. All right, where was I? Now, I've been configuring this manually, and as you can see, it's a little bit tedious. It's not quite as bad if we're not doing EVP and VXLAN, but I would never recommend doing this manually in production. So we will automate this in a minute, but I just want to get the configs right. All right, so what I want to do is I want to show that host 1A and host 1B use the same VLAN ID, but they're on two different layer 2 domains, even though that's the same VLAN ID. And so that's on leaf 1, show VLAN. Make sure that we have it set up in the, okay, so we need to set this up. Interface VXLAN 1. VLAN VXLAN VLAN 120 VNI 10,020. So that's what that's matching up with our diagram here. So outside will be 10 and 20. Outside here will be 10 and 20. So the frames that come in will be tagged with either VLAN 10 or VLAN 20. But depending on the port, they'll go to different internal VLANs. So we're setting up based off of the internal VLANs first. Because that's what the internal VLANs are, what's tied to the L2 VNI. And then we translate at the interface, at the connecting interface. I'll just mirror these over here. Same config on both sides. All right, so I think that looks good. And then now we're ready to configure the interfaces. Show LDP neighbors. All right, so we're wired the way that we want. We're wired this way. So yeah, so host 1, host 2, so it looks good. And then so Ethernet E3 Switch port mode trunk, switch port trunk, VLAN allowed VLAN 110, and switch port VLAN translation outside inside 10 to 110. Ethernet 4, that's plugged into host 1B, switch port mode trunk, switch port trunk allowed VLAN 210, switch port VLAN translation outside inside. I think that's what it is, outside inside. No. So if we do show VLAN, yep, that's what we wanted. Ethernet 3, Ethernet 4. So I'll go to host 1A. Okay, that looks good. Yep, and then I'll go to host 1B. Host 1B. And E1, no switch port, and E1 10. Oh yeah, did I set the MAC address? I did not. MAC address router. There we go. So we're hard setting the MAC address. I had too many zeros there. One is for B01 and one's for A01. Just to show that the MAC addresses go, we can overlap there. And then I should be able to ping my gateway. Oh yeah, IP address 10.1.10.11. So like rows up. It's down. Oh, yeah, encapsulation.1q VLAN 10. There we go. Oh, no, encapsulation.1q. There we go. I can ping my gateway. But if we look on leaf 1, show MAC address table, or show ARP, VRF, group A, and then group B, we see we've got the same IP address, but they're two different MAC addresses and two different VRFs, even though they're on the same VLAN. Ta-da! It's not Q and Q. It is VLAN translation. It's like NAT, but for VLANs. Because the frame comes into the interface with VLAN 10. Before it goes into the internals of the switch, it's translated into a different VLAN, does its VLAN things, and if it comes back out, if a packet comes back out, internally it's VLAN 110, and then before it gets sent out the wire, it translates to VLAN 10 back again. So it's a two-way translation. So we got it working. Let's see if we can get it working across multiple devices. So let's do VLAN 20 over here, and then also do VLAN 20. So that'll be on leaf 2. So the VLANs are instantiated, and let's do show LDP neighbor. 2A is on Ethernet 3, 2B is on Ethernet 4, so that looks good. Interface E3, switch port mode trunk, switch port trunk, allowed VLAN 210, or 220 rather. And switch port VLAN translation, outside inside 220. Oh, I did it wrong. This is easy to get mixed up. Switch port trunk allowed VLAN 120. Because that's group A. There we go. Now, switch port trunk allowed VLAN 220. Mode trunk. VLAN translation outside VLAN, inside VLAN. And it goes back and forth. You could do it just one way, so it only gets translated coming in, but doesn't get translated going out. I don't know why you would do that, but the cool thing is this works on the virtual platform. I don't know how far back it goes. Check something here on my phone. All right. So now we got to configure the hosts. So 2A. Encapsulation.1Q, VLAN 20, IP address 10.120.12, MAC address, router. Okay, so that's there. Show run interface VLAN 210. 220. Okay, so I got to do that. Interface VLAN 220, VRF group A, virtual, did I configure that? 210, I did not. Ethernet E3, switch port mode trunk, switch port trunk, VLAN 220. Oh, I did. Wait. Host 2B. Yep, no, it's right. Host 2B. No, yeah, I'm on host 2A. Yeah. Man, it gets hard to do this sometimes. Yeah, 120. All right, VRF group A, address 10.1.21, virtual. Yeah, I got it mixed up. All right, let's see if I can ping that now. There we go. I can ping it. I can see it there, and then host 2B. VLAN 20. Then here, interface VLAN 220, VRF group B, IP address virtual 10.1.21. And we can ping. Now on leaf host 2, or sorry, leaf 2, if I do show MAC address table, oh, I didn't set the MAC address. So MAC address router. No, it'll be in the, there it is. It's hard to keep track of all this stuff. Should VRF-A be able to ping VRF-B? No, they should not be able to, unless I route leaked, but even then it wouldn't work because they have overlapping IP space. So if they're overlapping IP space, you can't do it, even with leaking, or even, you know, be like, I can't even route them externally. But I'm just showing, yeah, I did this to show that we could completely overlap here. All right. So the demonstration is done. Now let's talk about how we would automate this. So, so I got some files to start off. When we do automation, what we're doing is we're taking a template and combining it with a data model. The template pulls the information out of the data model in order to generate the configs. So we're going to generate the configs, then we're going to push the configs. Right now, we're going to care about how we're going to generate the configs to do this. And I've got this fabric data model here that has basically all the information we need initially, because I use this for some other templates. The difference here is I've got different, I'm using IPv6 instead of IPv4 for my loopbacks. So I can pretty well change this up. And I've only got 2 leaves instead of 4. All this information is still the same. So this would just be 1 and 2. Get rid of that. And change my so for example, loopback 1, loopback 0 on my spine 1 is this address. And that'll be 102. We don't need the subnet mask. So we're just replacing the information because I know I'm going to need this stuff. To generate a config. Then I've got my VLANs here. So this is the information for that. And then I've got my template here. So this is a Jinja template. So this is the Jinja templating language. So it's going to pull some information out. How do I want to go about doing this? You know what? I'm going to do it this way. I'm going to rename. Okay, I'll make a new one called fabric.j2. And then I'm going to run that backup config again. And then use leaf1 as a basis of a template. So this stuff, for example, I can keep in there. I don't need to do anything with username this because it'll be fine. This will be fine. We're looking for the things that are unique. All right, so right now we've got, I need to create all the VLANs I need to create. And the information is in VLANs. So what I need to do is I need to loop through and I need to instantiate every internal VLAN. So that means I'm going to have to do some nested looping, which is like the most difficult looping to do. So, and what I can do here with this IDE is I can do right click and then open to the side so that I've got the information on both sides. And then over here, I'll also look at my old template because I did do it in here. So this is the same kind of loop. So I can just copy that. So for if leaf is in the host name, then do this because we're not going to do the VLANs on the spines. I'm also going to just comment this out as the original. So if leaf is in the host name, N4, for VRF and VRFs, that's not the right thing. So I'm also going to nest these loops. Otherwise, it's going to get really gnarly. So here's the if and end if. So what I want to do is I want to do for tenant and tenants. And probably what I would also want to do is I would want to do another level of VRFs. Crap. Let's do it this way. This is fine for now. For tenant and tenants, because most of the time every tenant has one VRF, but you know, this is really VRFs. Because I didn't really do tenants. Let's call it VRFs. All right, so we're going to loop through each one of these tenants, or these VRFs rather. no, tenants. Tenants and VRFs are two different things. Tenant is purely an administrative boundary. They don't show up in configs anywhere. So I'll do a tenant. We'll call it tenant A. Because the inconsistencies would bug me. All right, tenant A, or just tenant Coke. And then we got two different VRFs, group A, group B. That's fine. All right, so we do need to do a tenant loop. So for tenant in tenants, then this one would be how many? 2. There we go. And then I have to add another N4. All right, so those match them. There we go. So for tenant and tenants, and then inside of a tenant we have VRFs. So for your VRFs and VRFs, then we go into another loop. For VRFs and so this will be our VRFs and then group VRFA. And then for VLAN, for VNI in VRFs, make sure we're matching our 4s and our N4s. Then I think we have to do another recursive loop for no, I think we don't. Okay, I think we're good. So it would be VLAN. So it'd be VNI and then internal VLAN. And then that would pop out that number. So if I run this, I should get 4 VLANs. So what I'm going to do is I've got a playbook here called build. We're just going to build for leaf 1. I need to install Ansible lint. Pip3 install Ansible lint. All right, so we're going to do Ansible playbooks build. No inventory was found. Oh, because I don't have a config file. Whoa. Crashed. Should be in a Python environment. Yeah, I'm in a Python environment. I'm going to try this again. So my inventory, does it have leaf one? It does. Inventory.yaml. Oh, I did. Yeah, I did put in the config. So the config file tells it where to find Ansible, or the inventory file. Okay. Fabric type does not appear to be. That's okay. Tenants is undefined. Oh yeah, I need to do vars VLANs.yaml. VRFs is not defined. All right, so here we do the loop for tenant and tenants. For VRFs in tenants.vrfs. All right, so these loops can get really confusing. So if we do VLAN and then we do, let's do the first loop first. So just for tenants and tenants. So it spit out a config. It won't be a good config, but it'll spit it out. So tenant Coke. Okay, cool. Then the next loop. So just the name. For VRF in tenants, tenant. Oh, is this why I want to do a list? What did the old one do? And tenants, tenant. VRFs. Tenant Coke, tenant Coke. Shouldn't have done it twice. Should just do it once. Oh, that's right. Yeah, because it did. That's fine. Yep, that's A and B. Getting closer. Sometimes this is just how I have to do it. So then for VNI and tenants, tenant, VRF, VNI, VNI, N4. I gotta wrap it in the brace squiggle. For VNI and tenants, tenant, VRFs. So tenants, then the tenant, and then VRFs, and then the VRF name, and then VNI. There we go. Okay, then we get a list in there. Perfect. Yep, and that's as far as we need to loop, because now we can just do VLAN, VNI, internal VLAN. There we go. I think that should do it. Yep, that's what it was. All right, so we're just looping through there. So we've got that done. And then we need to do VRF instance, which will be very similar. We don't have to loop as deep. So this is often how I do templates, is I just go through a real config that works and then find the dynamic parts and then replace it. Because I think I just need to do that. Oops. Oh, yeah. Yep, that works there. So this I loop through a different part. So these interfaces, these are the point-to-point links. I get that information from my fabric because I loop through this list right here. Now I've actually got this somewhere else in my fabric.old. I could just cut and paste this part. Yeah, so if I just copy this. It should create the config for me. Yep, it did. So that I do need to change my fabric, my YAML, because my MTU is 1570 since I'm using IPv6 as my underlay. Okay. So then, okay, this part right here, this is going to be, how am I going to, I'm going to skip that one for now because I don't know how I'm going to do that one. But the loopbacks, yeah, I also have a loopback thing I can do. Oh yeah, I don't care about that. I want to go over here. There we go. Oh, I do need to change it so that it gives the IPv6. And that it's a 128, not a 32. And then in the VRF section, actually, I should add some more information. I should add an IP address. Okay. So I think, do I have, for my old one, do I have a, yes. So I can use part of this loop thing. Put that in there too. All right, so we're looping. If leafs is in there because we don't care. If we're a spine, we're not going to do any of this. Indenting my four, otherwise I get really lost. So I'll copy this part first to get to the VLAN part. That lets me know that I'm missing an N4. So let's get that in there. And then how do I pull out the VLAN ID? That right there. And what did I call it? IPv4 Anycast. All right, so let's see if that worked. I built something. That looks good. Yep, that's what it's supposed to look like. I'll throw in a no auto state as well. That just means that the interface will, the SVI will be up even if there is a even if there's no there's no interface that has that VLAN on it. Yeah, so that's what it should look like. Except it'll be capitalized. It doesn't really matter, but just keep it consistent. All right, so all that's done. And then for interface VXLAN. All right, I'm going to go take a restroom break. I'll be right back. I got myself some protein powder. I went to the restroom. Okay, so we need to generate this part of the config. I think I had this. Where's the VXLAN part? Yeah. I'll use from a different there. Can add this in here. Oh yeah, it's already there. So we got to do the tenant loop again. Trying to keep all this consistent. Okay. So for tenant, VRF and VRFs. See what that does. And a print statement. No, didn't like the blank. Okay, so that worked. We just need to put the VNI in there. So where do we get the VNI? L2 VNI. I think that'll do it. So we're going into tenants here, tenant Coke, VRFs, the VRF group A, and then we want the L3 VNI, not the L2 VNI. Yep, that's what we wanted. And then we loop through. We do another loop, and a further nested loop to get the actual VLAN IDs. which we did before. So I think we're in there. Are we in VRF VNI? Nope, we need one more loop. So up to that, we need another loop. Gets easy to get mixed up in this. An internal VLAN and then VNI. The L2 VNI. Oh, L2 VNI. It's kind of tedious, but once we get it, it's saves us a ton of time. So that's what we get there. That's what we wanted. I think that's it from that. And then we need to loop through the VRFs. IP routing. And then loop through the routes. Or the VRFs, rather. But we need to, for tenant tenants for VRF, we need to we'll do that. So do we do a VRF instance? Yeah, we did. Okay. Let's do it one at a time. So IP routing, VRF. And then we got the big, this big part right here. It says all of this. Oops, all of this. Oh boy. All right. I'm going to call it a day. This has been quite a bit. Any questions? It's getting late here, so. You know, I'm just going to keep going. I'll do it. There's no one really watching. Okay, this is from Fabric. Okay, so that's okay. Oh, I'm gonna need a router ID. Okay, that looks good. Looks good. I don't need IPv6 originate because it's just all IPv6. All right, another VLAN deep dive here. So we'll copy. Make this smaller. VLAN, interior VLAN there. Except that's all the way up here. If you've ever worked with if you've ever worked with Jinja, it's the making sure your for loops are closed. If you lose track of them, it's real annoying. Ask me how I know. Because unlike Python or even C, your loops have to be closed by an end or an if statement or an or a loop rather has to be enclosed by an end. Before I figured out, or before I learned you could do spacing for nesting, it drove me nuts. Okay, so VRF. Loopx. Oh, maybe router ID. Okay, let's try that. VLAN is undefined. Another problem is sometimes it doesn't tell you where the problem is. That's right there. There we go. All right, cool. Look at that. It can be a pain to set this up, but once you have the template, then it gets a lot easier. So anytime you're doing automation, you're increasing your upfront workload, but you're dramatically increasing your back-end workload. Be right back. You did something to mix my protein powder. All right. So I think we're ready to try to build for the larger fabric itself. Let's see if we have enough information here. And it did. Oh, the template. We did some translation stuff in there, yeah. Let's try that again. I can test this on spine 2 because I don't think spine 2 is configured. Okay, I see one mistake here in the template. It's the address family. It's IPv6. Oh, crap. I copied the wrong... No, did I copy the wrong? Oh, I did. Yeah. Okay. So yeah, it's I didn't put it into the. That's why I couldn't find it. I was like, what happened to it? All right, what am I missing? It didn't look like I looped correctly in the BGP part for the neighbor interfaces. There's no underlay part. Oh yeah, I don't think I did. I think I did a pure filter. Yep, I need to do a pure filter here. There we go. I got the routes. I don't have a route for 102, so leaf. Because I didn't put the right route in there, did I? Spine 2. What the heck route did I put in there? This is why it's important to know. Oh, because, yeah, it's a 128. Duh. This is why it's important. If you're doing automation, you have to understand what you're automating. As Admiral Kirk says, you have to understand why things work on a starship. Okay, now we're established there. We good? I don't know why it's trying to do IPv6. Especially when we're now. Oh, the router ID. That was borked. Ooh, yeah, that's not good. Fixing the router ID problem. Oh, yeah, because it's still in there. That's why. That's what we're looking for. 2 IPv4, 2 IPv6. Okay, so now I've got a template that seems to work. I think I'm good to call it a day. Oh, yeah. I want to do one more thing. I want to be able to deploy this. So do a complete config replacement. So I might need to okay, I got some syntax errors in here. So we'll just copy this and then find it in the yeah, so it's the wrong format there. So what was yeah. Another thing about IPv6 is you've got to get the syntax right. So we'll do a build and deploy. All right, didn't like something at group A. This right here. It shouldn't say VNI. The BGP config. Yeah, just VRF. Build. Deploy. There we go. Well, that didn't work. How are they established? Must have stayed up. So so the underlay is not working right now. Don't see any neighbors. Oh, you know what? Because I think I had the interfaces wrong in my fabric. Yeah, it's 1 and 2. Easy fix. Now once you got everything going, it gets easier and easier. So they're not active for some reason. No, we do have a remote AS number. Ethernet 1 and 2. Activate. It's not even tempting. Unless I need to clear some stuff. That didn't need to do anything, so why am I... Where's 1? Why are you different? Oh, there it is. There's one of them. Don't know why that... I didn't do anything. Is that a timer thing? No, it just took a second. I don't know why. All right, so cool. Now I'm going to call it a day. Okay, question. Yeah, there was another question. How much documentation do you do ahead of projects like this? As much as I can, and most of my documentation is going to be in the form of like a PowerPoint. Like, this is what I do to document. You know, stuff like this. And then in the data models, other stuff gets captured in the documentation. Let me just start over here. So then the data models become the documentation as well. So I've got 2 YAML files which tell me exactly how to configure everything, or how everything is configured. I've got one tenant called Coke. I've got 2 VRFs. This becomes my documentation. And then it's just a matter of, you know, there's a trade-off. Like, if I were to do a production implementation of Arista EOS switches, I would not probably use this method. I would use something called Arista AVD. AVD is very similar to this. It has data models and there's templates, and it will build configs, except it's done all the template work. You just edit the data models, the YAML. They've got very strict schemas, but it's very flexible. You can do any kind of underlay, any kind of overlay, but it doesn't do this VLAN translation. So that's why I'm using this method. So this is me raw dogging Jinja versus using someone else's framework. AVD is a wonderful framework, does all the work for you, or most of the work for you. But if it doesn't do what you need it to do, then you have to do this method. You have to raw dog some Jinja. So this is raw dogging some Jinja. It's fine. I mean, I set all this up in 3 hours. I could build a 100-node fabric with this. And, you know, it took me 3 hours basically to build a system that will build 100 nodes or 200 nodes or 400 nodes. I just have to fill in all this stuff here for those nodes, maybe another hour. And then after that, anytime like, oh, I need to add a new, like, now look how easy it is for me to add a new L2 VNI. So I just added a couple lines of YAML. I'll build. Oh, I need an anycast address too. and now I deployed. So now it's deployed. So doing that kind of thing, like doing all the work ahead of time, and getting kind of lost in the weeds in these templates, it's a little bit tedious, but that's the work you do ahead of time, and then afterwards, it's amazing. AVD for Arista, AVD for Arista actually does auto documentation too. It'll build a fabric document MD file as well as an individual device MD file. But it doesn't do VLAN translation. Not like this, at least. So I don't know if this would ever be worth doing in production. This is me fooling around, seeing, like I think I know what gotchas there would be, but I got around them. And thinking about, how I'm doing the internal VLANs versus the external VLANs. But yeah, I don't know if this would be a good solution. Yeah, 90% of your work is documentation. 90% of my work is data models and templates. And they kind of auto document. Because if you're like, what VLANs do we have? Well, here it is. It's there. That's the documentation becomes the config. So that's the nice thing about data models is the documentation or the documentation becomes what we pull this from. So you can consider this documenting your network, your VLANs and your SVIs. And then your configs reflect this. So the thing about this though is now you cannot go in and manual configure your device because watch what happens on here. So if I go to leaf 1, show VLAN, I've got 120, 130, 110, 210, 220. Let's do VLAN 333. Okay, so show VLAN 333. Now I do a new build of my configs and then I do a deploy and I go back to leaf 1. VLAN 333 isn't there anymore. I call this the Genesis torpedo method of configuration management. Configs go one way. It goes from the data models through the template and it gets pushed to the device, overwriting whatever's on the device. Now, EOS and NXOS and Junos are gentle when you do this. So for example, I've just pushed a config, it replaced the entire config. It did a complete config replace, but it's been the session's been up for 6 minutes because I didn't change anything in the BGP config section or anything that would relate to neighbors. It did not tear down and have to reset up the renegotiate the BGP session. So yeah, I do have a free course. If you look in my, I have a free course of network automation. Starts you out very gently with this kind of thing. If you go through my playlists on my account, you'll see a free course for Ansible and automation. I love automation. I mean, like think about if this is how you ran your network. It's auto documented now. I don't have to worry about what's on the configs because it reflects what's on here. It is a skill set you'll have to acquire, and it's not a low learning curve. I'd say about a medium learning curve. But once you have the skills, you're like my life as a network administrator after I learned automation is very different than the life before, and I much prefer the life after I learned automation because it solves so many problems. Like network automation is a big, expansive topic, and it's very easy to get lost in the weeds. If you do 3 things, if you do 3 things with network automation, you've gotten 90% of the benefit. because there's like pipelines and CI/CD and all that stuff, and that's fine. You don't need it in most situations. And some situations it can really help, but in a lot of situations it doesn't really matter. But if you do 3 things, number 1, if you build configs from templates and data models, build your configs from templates and data models. No more manual configuration. If you make a change to your network, you make it in this YAML first. So number 1, build your configs from templates and data models. Number 2, deploy your configurations through automation. It could be a Python script, it could be Ansible, it could be Vagrant, it could be something else. But do not cut and paste anymore into terminal windows. You saw me do it a little bit here because I was playing around. But for your production environments, do not cut and paste or copy and paste into a terminal window. There's so many problems with that. And it has caused so many problems. Like if I've got a big config, like here, I'm going to copy. I'll go into Leaf 2. And I'll do config. And I'm going to do, I put a typo in there. And then I paste. It looked like it took everything, but it didn't take that because it's a typo. So if I didn't have there already, then this wouldn't go in there. So I wouldn't know because it pasted so quickly. I didn't really see any errors. So use automation to get your config into your devices. And then number 3, and we haven't done anything like with that here, is use automation to do a post-deployment validation. You know all the show commands that you run to see if your configuration worked? Well, you can automate that. There's different frameworks like PyATS and Anta for Arista. You can write your own test suite. So every time you do deployment, just run it. It'll just make sure your VLANs are instantiated, your BGP sessions are established, that kind of thing. And then that's going to, those 3 things. So build your configs from a template and a data model, deploy them through automation, test them through automation. And that completely changes the game. So, all right. I'm going to go ahead and cut this out, and it'll be on my account, so you can watch this and at your leisure and go through anything you like. Thank you for watching.